Tuesday, we're looking at 2.6, and we're going to talk about conditional statements. There is more than just conditional statements to it. We're also going to just talk about like symbolism and logic symbols. So we're going to do those notes today. The practice is going to be in Alex, because again, Delta Math really doesn't have much on it. If you started the extra credit in Alex yesterday, you may have seen some questions. You're like, what the heck? We haven't done this yet. We're doing it today. Okay, that's all going to be in today's notes. So if there was stuff that you hadn't seen, that's what we're covering today. So there will be a practice for today. Okay, and then tomorrow we are just going to have a practice day to reiterate the topics of today, because it is kind of a long set of notes. Okay, so we'll have tomorrow to practice. We're going to do some class activities. We're going to do Math Zebra again and some other stuff. So the practice, the Alex practice that's being assigned is not going to be due till Thursday. It's not due tomorrow. It won't be due till Thursday, because we're going to have some time to work on it tomorrow as well. And then I'll hand out your reviews tomorrow, and we'll have a review day in class Thursday, and then the review will be due on Friday, which is our test day. And if you are choosing to do the extra credit, it would have to be done by Friday morning at 7:20 a.m. Okay, any questions about our calendar? Okay, all right, so let's take a look then and get started on our notes. I told y'all to hang on to that 2.5 geometric proofs packet or practice because the very top question was about Euclidean geometry organization, and we hadn't talked about it. For some reason, this whole section right here got left off of the last note, so I added it here at the beginning of these. So here it says add on from 2.5 proofs. So Euclidean geometry, we said that word at the beginning of the year. I told you all Euclidean geometry is just your everyday geometry. Euclides was a mathematician back in the day, okay? But this is the organization of the parts of Euclidean geometry. So it starts with the basis of your undefined terms. We talked about what those three undefined terms were back in Unit 1. Does anybody remember the three undefined terms? Like, we can describe them, but they don't have a formal definition. Ian? Point, good. Nathaniel?
Plane.
Plane? Line, good. So point, lines, and planes are our three undefined terms. Because a point is really just a location. It has no size or shape. A line has no size. We can't measure it. It goes on forever. It's one-dimensional. And a plane also goes on forever, but it's two-dimensional. It goes on forever in all directions. So those are technically undefined. We can describe them as best we can, but there's not a formal definition in geometry for point, line, and plane. Okay, so that's the basis. That's what we start with. Then you can use those terms to define other terms. Okay, so defined terms are terms that have a formal definition. Okay, and you can use other terms and even undefined terms in those definitions. So for instance, like array. Array is defined, and in the definition of array, we use point, right? So point is used in the definition of array. Yeah. All right. So then after undefined terms, then defined terms, the next thing is postulates. I told you we talk about the difference in a postulate and a theorem because these are both used. There are postulates and theorems that can be used for our reason column in our proofs. Okay, we went over some of those postulates and theorems in yesterday's notes. Okay, but the difference is a postulate does not require proof, and it's presumed or accepted as true. While a theorem is a statement that requires proof. Okay, so a theorem requires proof. A postulate does not require proof. Okay, and a theorem requires proof using logic and reasoning. Okay, so that's the difference in a postulate and a theorem. We feel okay about that? All right, so now you should be able to fill in that very first top part of yesterday's practice, where it's just asking you to order Euclidean geometry. That's this right here at the top. So you can go ahead and fill that in. And then when we don't get up now, please, but when we finish the notes, then you can turn that practice in. Now that you have it filled in. Okay, we feel okay about that? All right, so let's get into 2.6 then. Okay, so we're going to start with the basics, logic and symbols. Okay, so first of all, a statement, just a statement in general, is a sentence that is either true or false. Okay, a statement is a sentence that is either true or false. Okay, whether it's true or false is called the truth value of the statement. So the truth value is either true or false. Okay, we often represent statements using a letter, most often P and Q, but sometimes we'll have more than two statements, so then we'll get into R or other letters. Okay, so for example, if statement P is a rectangle is a quadrilateral, the truth value is true. A rectangle is a quadrilateral. That is a true statement. Now, if we negate a statement, a negation of a statement has the opposite meaning. Okay, that also means it's going to have the opposite truth value. Okay, to notate a negation, we use a tilde. That's this in front of the P, this little squiggle on your keyboard. It's like the top left of your keyboard next to the 1, I think. Okay, so a tilde represents a negation. We read it as not. Okay, so I read this as not P. Okay, is a rectangle is not a quadrilateral. And the truth value of that would be false. Because the original statement P was true, so its negation must be false. Negations have opposite truth values. So far, so good? Okay, now we can combine statements. If we combine multiple statements with the word and or, we're creating compound statements. Compound statements that use the word and, that has and. It is called a conjunction. And the symbol for that is down here. That is read as P and Q. Okay, so and is a conjunction, and this is the symbol for it. Okay, so if statement P says a rectangle is a quadrilateral, and statement Q says a rectangle is convex. Do you know what convex means? Do you know what concave means? Like concave, it's like folding in or falling in. Convex is the opposite. It's bowing out. Okay, so a rectangle is a convex shape. A star is a concave shape. As you know, like the vertices of a star go in. There's in and out, but parts of it concave. Okay, a rectangle is convex. Okay, so these are our two statements, P and Q. Individually, both of these are true. Okay, so they each have a truth value of true. When you create a conjunction, P and Q, you would write out a rectangle is a quadrilateral and a rectangle is convex. The truth value of a conjunction, it can only be true when both statements are true. So in this example, both of these are true, so the conjunction is true. Okay, but if one of your statements is false, the conjunction is false. Does that make sense? Okay, so let's try it here. It says use the following statements to write compound statements for each conjunction and find the truth value. Okay, so our three statements, and here's the picture that they give us. It says statement P, the figure is a triangle. Is that true or false? Statement Q, the figure has two congruent sides. Yep, that's marked. Statement R, the figure has three acute angles. That is false because one of those angles is labeled as 90 degrees, isn't it? Okay, so we've got two true statements and a false statement. Now we want to create conjunctions of those. So this first one says P and R. So I'm going to I would practice your symbol that would be written as P and R. Okay, so if we do P and R, it would read, the figure is a triangle and the figure has three acute angles. One of those is true, and if you want to put that over here, the P was true, but the R was false, wasn't it? So if one of them is false, what's the conjunction? False. So this statement, this conjunction is false. Okay, now B, how would I read this, do you think? No. Q and what's that squiggle in front of R? What does that squiggle mean? What did we say up here? It's the negation, and we read it as not. Okay, so I would read this as Q and not R. So if you need to write that, Q and not R. Okay, so statement Q, we said is the figure has two congruent sides, and we already established that Q was true, right? Now, not R is the figure does not have three acute angles. Is that true or false? True. That's actually true because R was false. So not R must be true. So since both statements are true, this conjunction is true. Y'all follow? Okay, so we're thinking logically. We're using our logic skills to think through these truth values. All right, so that's with and. The other type of compound statement uses the word or. So if you use the word or, it is called a disjunction. And the symbol for a disjunction is here. I've made that P hard to see. I'll go over that in black. Okay. So when we have an or compound statement, it's called a disjunction, and a disjunction can be true if either one or the other of your two statements in the disjunction are true. If either one is true, the disjunction is true because it's an or statement. So in this example, statement P says Sarah teaches geometry. I'm Sarah, so this is true. Okay. Statement Q says Sarah teaches chemistry. That's false. I do not teach chemistry. So then this disjunction, this is red, P or Q. How you read that. And there is a typo here because it has the word and. This should be or. So make sure you fix this to or. so that this is correct. Okay, so the disjunction would be Sarah teaches geometry or Sarah teaches chemistry. That's true because one of those statements is true. The disjunction is true. Do y'all follow? So if it's an and statement, both have to be true for the conjunction to be true. If it's an or statement, only one of them needs to be true for the disjunction to be true. So far, so good? All right, flip it. Let's try this example. Okay, it says use the following statements to write a compound statement for each disjunction and find its truth value. Explain your reasoning. Okay, it says January is, so statement P, January is a fall month. Is that true or false? Statement Q, January only has 30 days. There's 31 days in January.
Oh, false.
January 31st is actually my wedding anniversary. So I know there's 31 days in January. All right. R, statement R. January 1st is the first day of a new year. That's true. January 1st is the first day of the new year. Every year. January 1st starts the new year. Okay, so I've got two false statements and a true statement. Okay, so this first one asks me to write Q or R. So again, just to practice, I'm going to put the symbolism. So it would be Q or R. So written out, that would be January has only 30 days, or January 1st is the first day of a new year. So is one of those true?
Yeah.
Yes. So the statement is true.
Oh my God.
And again, if you need to put it over here, Q was false, but R was true. So as long as one of them's true, the disjunction is true. Okay, B is over here on the right side of the calendar picture. This one would be read P or Q. P or Q. Okay, so is P true or false on its own? P is false on its own. Is Q true or false on its own? False on its own. So January is a fall month, or January only has 30 days. Since both of those are false, this statement, this disjunction is also false.
Whoa. That is hungry.
All right, C, how would I read this symbol? Not P or R. Okay, so I'm going to write that out. How I read that. Not P or R. Okay, so if P was false, what is not P going to be? Not P is going to be true, because not P is going to be January is not a fall month. Now that's a true statement. So not P is true. And then R was also true. It was January is the first day of the new year. So here both of them are true. I only needed one of them to be true for the disjunction to be true, but they're both true. That's fine. So if at least one of the statements is true in an or compound statement, the disjunction is true. But if neither is true, then it's false. Now, all these truths and falses can get a little confusing. So a really convenient method for organizing your truth values is using what's called a truth table. So truth tables can be used to determine truth values of negations and compound statements. So the basic, let's start with this little table. This is just a negation. Whatever your statement is, P can either be true or false, right?
Right.
Okay, then the negation of P, the not P, would be the opposite. So if P is true, not P is false. If P is false, not P is true. Does everybody understand negation? It's just the opposite truth value. Yes. Okay. Now, if we are dealing with a conjunction here, we'll have our two statements. So I have my P column and my Q column. So here are all the possible combinations of P and Q. They could both be true. P could be true and Q false, or vice versa, P false, Q true, or they both could be false, right? So we have four possible combinations. So then I have the conjunction P and Q. The only way P and Q can be true is if both P and Q are individually true. So for a conjunction, there's only going to be one true in your truth table. The rest will be false. Because for the conjunction, for our and statements, both have to be true. If you need to write and above this, so you remember this is and, disjunction is or. Okay, so I have the same PQ values, okay, either both true or true false or false true or false false. Okay, but when I change this to or, now only one of them is false. Because if they're both true, the disjunction's true. If P is true, the disjunction's true. If Q is true, the disjunction's true. The only way for the disjunction to be false is if both are false individually. Y'all understand the difference? Okay, so we're going to try creating a truth table. So the process in creating your truth table is here. Okay, you can read through these little things if you want to, but you're always going to have your P and Q column, or whatever your statements are labeled, P, Q, R, S, whatever. So you'll have a column for each statement. Then if your compound statement has a negation, you need a column for the negation. And then whatever your compound statement is, you need a column for that. Okay, so I have P and Q. My compound statement is not P or Q. So I have to have a not P column. So remember the PQ column, this is never going to change. This is always going to be the same. There's these four possible combinations: true, 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 false, false, true, false, false. Okay, so those two columns don't change. Okay, the negation column should be the opposite of the original. So not P is just going to be the opposite of P. So instead of true, true, false, false, I'm going to put false, false, true, true. And then you look at your and or statement, whatever your compound statement is. In this one, it's an or. So not P or Q. So I just need the not P column or the Q column to have a T. So here's the not P, here's the Q. As long as one of these is true, this is true. Here, both were false, so this is false. One of them's true, then this is true.
Yeah, no.
Are we feeling okay about this? Okay, we're gonna fill this one in. The P and Q column are always the same. They can both be true. One can be true and one false, and reverse it, or they can both be false. Those two columns are always going to be the same in all your truth tables. Okay, now the negation, the complex or the compound statement here that I'm trying to figure out if it's true or false is not P and not Q. How you would read that. Not P and not Q. So since both of them have a negation in front of them, I need a negation column for P and a negation column for Q. So I need a not P and a not Q. Well, not P is just going to be the opposite of P. So I look at the P column and write the opposite. For not Q, I look at the Q column and I write the opposite. So far, so good? Now, this is a conjunction. It's an and statement. So for it to be true, don't both parts have to be true? Okay, so because of that, that's supposed to be yellow. Because of that and, that symbol there, I need both to be true, the not P and the not Q. Where does that happen?
At the bottom.
At the bottom. So that's the only one that's going to be true. All the rest of these will be false. Are we okay with it? No? This table underneath here, this concept summary, I'm not going to read through that. That kind of just puts it all together in one spot. If that's a nice reference for you, you can use that. Okay.
They're both wrong.
That would be the only way that.
They're both right.
Because I hear some good conversations happening at some tables, so I just want to help reiterate. Remember, the tilde is the negation. We know that means not. It's going to be the opposite. Okay, when we're talking about whether or not the compound statement is true or false, okay, the compound statement either has an and or an or. When we say and, we mean both. And means both. So for an and statement to be true, both parts have to be true. Or that's either or. You hear either or together a lot, right? Either or. So if it's an or statement, either one can be true for the or statement to be true. Not sure if that helps, but and means both. Either or means either. Okay. All right, let's flip to that last page. So now we're going to get into some other types of statements. So that was compound statements. Now we're going to talk about conditional statements. So a conditional statement is simply a statement that can be written in the form if P, then Q. Q and P are just, we said we use letters to represent statement. So P is some statement and Q is some statement.
Can I make it 1 and 2?
No, because you need to know P and Q. We use P and Q in all of them. Okay. All right, guys, listen. Do y'all remember reading when you were little? If you give a mouse a cookie, that book?
No.
Or if you give a moose a muffin, or if you give a pig a pancake, you all read those books before? Those books are just full of conditional statements. Okay, so the synopsis or the beginning of the if you give a mouse a cookie book goes, if you give a mouse a cookie, then he's going to want a glass of milk to go with it. Okay, so my if is you give a mouse a cookie, that would be that's called the hypothesis of the conditional statement. So the hypothesis is the P portion. That's what comes after the word if. The Q, that's what comes after then, is called the conclusion. Okay, so if you give a mouse a cookie, then he's gonna want a glass of milk to go with it. Give a mouse a cookie is the hypothesis. That's your P. He's gonna want a glass of milk. That's your conclusion. That's your Q. Are you following? Okay. So now, once we establish what our hypothesis and conclusion are, what part is the P and what part is the Q, we can then rearrange these and negate these to create related conditionals. So the conditional symbolism is P, and then this arrow to the right, Q. So this is your original conditional statement. So if you give a mouse a cookie, then he's going to want a glass of milk. Okay. One of the related conditionals that we need to be able to write is called the converse. And what the converse is, it exchanges the P and the Q. So notice in the symbols over here, instead of P then Q, it's Q then P. So it switches the order. So it would be, if he wants a glass of milk to go with it, then you gave a mouse a cookie. You just switch the order. Does that make sense? Converse exchanges the order or switches the order. The inverse negates both parts, the P and the Q. So notice in the symbol, it's not P, then not Q. So that would be, if you don't give a mouse a cookie, then he won't want a glass of milk. So I just added not to both parts. Are y'all with me? Inverse means not, right? Now the last one here in this table is called the contrapositive. The contrapositive is the combination of converse and inverse. You are exchanging and negating. So see in the symbols, it's not Q, then not P. So it would be, if he does not want a glass of milk, then you did not give the mouse a cookie. So converse switches the order, inverse negates. Oftentimes those are mixed up, converse and inverse. The way that I remember it, my memory trick, is that inverse has an in, like not.
Whoa.
Inverse, not, negates, in. Okay, converse just switches the order. Inverse, not. If that helps you.
Why would you exchange and change?
That's called the contrapositive. It's
Change both of them.
no. If you're negating for these conditional statements, you're negating both. You're not negate. You're not going to negate one. It's both.
It's not this.
It would be, it's not this because not this. It's either going to be negated on both sides or neither side. Okay, let's keep talking and then we'll look at some examples. Okay, now the final type of conditional is called a biconditional. What does bi mean? Two. So you can write a biconditional statement only if both the conditional and its converse are true. So if both the conditional and its converse are true, it needs to work in two directions. Okay, bi means two. So if you can read your statement in two directions, P then Q and Q then P, and they both are true, then you can write a biconditional. And a biconditional uses the phrase if and only if. So instead of having if then, you have if and only if in the middle. So here are symbols. You can see the conditional is if P then Q. The converse is if Q then P. If both of those are true, we create this new symbol, this biconditional, where the arrow goes both ways. Because it's P if and only if Q. That's how you read that. P, if and only if Q. And this is the symbol form. So for example, if an angle is a straight angle, then it measures 180 degrees. That's a true statement, right? And if I flip it and I say, if an angle measures 180 degrees, then it is a straight angle. That's also true, isn't it? So the biconditional can be written as an angle is a straight angle if and only if it measures 180 degrees. So the if and only if is in the middle. It's P if and only if Q. Let's try this. Okay. First, let's make sure we understand hypothesis versus conclusion, because that's identifying our P and our Q. Remember your hypothesis. Oh, I think I did. Let me make sure I do the right colors. Oh, I did hypothesis in blue. Okay. So your hypothesis is your P. It's what comes after the word if. So if you lead, then I will follow. What's the hypothesis? You lead. Okay. The conclusion comes after the then. It's your Q. So what comes after then in that statement? I will work, or I will follow, sorry. Okay, so you lead as P, I will follow as Q. That's my hypothesis and my conclusion. Oh, I meant to, I should have circled that, not underlined. Not bad. Okay, what is the hypothesis in number 2? If is not part of it. It's what comes after if. So I do my homework. And then what is my Q? What is my conclusion? Okay, what is my hypothesis in 3? And my conclusion? Very good. Do we get the idea of identifying P and Q? Okay, once you're able to identify P and Q, then you can write all of these different related conditionals. So here's my given conditional statement. If a polygon has 3 sides, then it is a triangle. So a polygon has 3 sides. That's my P, my hypothesis. Okay, it is a triangle. That's my Q. That's my conclusion. So far, so good? So now I want to write. I'm going to type, so it's a little faster than me handwriting. Okay, I want to write the converse. So the converse switches the order. So instead of starting with a polygon, I still start with if, okay, but I'm going to start with my Q. So it is a triangle. Then, and then I end with my P. A polygon has 3 sides. I'm going to make that a lot smaller. That's really big font.
Then D or then A? Yep.
Say again?
If it is and the polygon. Then D.
Yeah, you can say B instead of A there. That's fine. And guys, if you're trying to be real grammatically correct, I know a lot of people don't like to start with it since it hasn't been defined. So you could actually leave polygon at the beginning. You could say if a polygon is a triangle, then it has 3 sides. So you could leave the polygon and the it where they are and just switch the has 3 sides, it's a triangle part. That's fine too. Okay, let's do the inverse. Okay, so the inverse is going to negate the original statement, the original P and Q, right? So the original P is a polygon has 3 sides. So now it's going to be a polygon does not have 3 sides. So if a polygon does not have 3 sides, then it is not a triangle. Yep. Both of those are true statements, right? Okay. What about the contrapositive? The contrapositive, it switches the order and it negates. Oops, that's not what I wanted to move. So I switched the order to put the triangle at the beginning, but I need to say it is not a triangle, then a polygon does not have 3 sides. Okay, so I'm going to underline in my colors to color code this for y'all.
Did you say that a lot?
All right, so my P was the polygon has 3 sides. So here I switched the order and I put Q then P. Inverse, I negated, I put that word not in both my P and my Q, but I kept the order the same as the original. And then in the contrapositive, I switched the order. So I put the triangle at the beginning and the 3 sides at the end, and I negated. Are you understanding the difference? So you're just rearranging your statements to create these related conditionals. Now, a biconditional can only be written if both the converse and the original conditional are true. Are both, hang on, are both the conditional and the converse true? If a polygon has 3 sides, then it is a triangle. Is that true?
Yeah.
If it is a triangle, then a polygon has 3 sides. Is that true? Yes. So I can write the biconditional. I can say a polygon, I don't start with if in biconditional. I start with my P. A polygon has 3 sides if and only if it is a triangle. I'll make that smaller. Okay. I'll post the video. The practice is in Alex,
All right.
but it's not due till Thursday. If you don't get to it today, it's not a huge deal.
Miss Viola, I need something for you to sign.
Now, one sec, I'm gonna finish this video. So the biconditional has the if and only if. Because this was true and this was true, I was able to write the biconditional. Okay, so on these, you're just trying to identify which one is the inverse, converse, contrapositive, or biconditional. So I would identify my P is you wash. Okay. My Q is I dry. So if you wash, then I dry is my original statement. This next one says, if you do not wash, then I will not dry, but it kept the same order. It kept wash at the beginning and dry at the end. So the order didn't change. It was just negated. That is an inverse. If I dry, so that brought dry to the beginning, then you will wash. So that switched the order. It didn't negate, it switched the order. So that is the converse. You wash if and only if I dry. So if you see the if and only if, that's your biconditional. Okay, and then last but not least, it's got to be the contrapositive, but let's double check it. If I do not dry, so we moved dry to the beginning and negated it, and we moved wash to the end and negated it. So we switched the order and negated. That is contrapositive. Okay, so you try those others. I'll post the key with them done, but that's what you're doing here. You're trying to make sure you can identify the difference in an inverse, converse, contrapositive, and biconditional. Okay, I stopped recording.